Welcome to Data Analytics 2 series. I am Dr. Danielle Morin from Concordia University in Montreal, Canada. The session today will be about logistic regression, and we will use frontline solver data mining. In order to illustrate the use of logistic regression, we will consider the following example. We have a data set of 40 observations where y corresponds to the success variable. Y will take a value of 1 if it is a success and the value 0 if it is not. We also have variable x1, x2, and x3. They are the independent variable that will be used to classify observations. They are my independent, I can call them also my exploratory variable. We will use a partitioning, that is, I will select this data set and break it into two parts. 60% of the observation will belong to training set and 40% will belong to the validation data. And we will classify observation. x1 is 50, x2 is equal to 2, and x3 is equal to 0. Let us go to Excel and perform the logistic regression. We are now in Excel where we have the data about variable y, x1 and x2 and x3, and here I have the observation that I want the model to predict. So let us start our analysis by inputting this data into classify. We will use the logistic classification. I will be asked to give the data range, which is here. The variable that will be used as my explanatory variable are x1, x2, and x3, and the output variable is y. We have two classes. We have those at y equal 1 and those at y equals 0. The success class is identified by 1, and the success probability cutoff is 0.5. We are asked to partition the data, so this is part of the pre-processing of the data. So if I click here, partition, I'll ask my partition, and I will decide what I want. So I would like to have 60% in my training set and 40% in my validation set. I always set the seed at 1, 2, 3, 4, 5, which means next time I will rerun the test, I will have the same partitioning. This is done. I will not rescale the data in this case. Rescaling the data, this is where we decide if we want to standardize the data or not. And this is done frequently when I am dealing with different units, for example, with money and age and time and so on. In this case, we will not do it. We also have here a variable that is the feature selection. This is when I have many independent variables, and I may decide to ask one of the feature where I can select either backward, forward, stepwise, or best subset to have the best regression, logistic regression. The next information that will be asked from me is what do I want to see. I may want to have a full report, and the report will be for the training data, which was 60%, and my validation data, which correspond to 40%. I only ask for the summary report. And now I want to score a new data. So this one I need to identify where is my new data. So I will get the range of my new data, which is here. The system will select this observation and classify them. As we note, I have used the same titles, therefore I will match them by name. And here we go. The first part of the printout repeats what I just did. We have asked for random partitioning, and we have used the seed value at 1, 2, 3, 4, 5. We have asked 60% of my 40 observation be in the training, which is 24. We've asked that 40% of my observation be in the validation set, which is 16. We did not rescale the data. We need an intercept. And we are here. We did not ask certain information, but we did ask an analysis of the coefficient. The first table that is here gives me the number of iterations the system had to use in order to give us this information. The residual degrees of freedom is 24, which makes sense because I have 24 observations in the training set, and I needed to estimate 4 coefficients. I need a value for B0, B1, B2, B3. The residuals in here and the coefficient of determination is 46%. Here we go to the table of coefficient. I can obtain my logistic regression by identifying those coefficients. Now here is my regression equation. My logistic, I should say, the probability that an observation belongs to class 1 is obtained by taking 1 over 1 plus e to the minus, and the coefficients are here. And I only kept 4 decimal. So it is minus 118562 plus 01553x1, 1.3135x2, and 0.0982x3. This table of coefficient also tells me the p-value, the significance of each coefficient. It is possible that some coefficients are not significant, but they will be useful to the classification. These are the results for the classification for the training set. In the training set, I had 24 observations. And we have the class 0 error rate of 0%, the class 1 error rate of 44.44% for an overall error rate of 16.67. The matrix here will summarize all this information. The number of correct classification is 20. We have here the percentage of accuracy is 83.33, which is the 1 minus the overall error, which was 16.67. We have the specificity, which is 1 minus class 0 error rate. Sensitivity, it is 1 minus class 1 error rate, and so on. I have the results of this. We keep in mind that the measures, the classification, and the error rate are obtained classifying the data that was used to generate the rule. Therefore, we will have to now test the rule that we have developed using a validation set. Here we have the validation set here. It will give me now different measure. It's telling me that the class 0 error rate when I test the model with an independent set of data is no longer 0% but 42.86%. My class 1 error rate is at 33.33 and the overall error is 37.5, which is much higher than 16.7. The accuracy of my model, I can see it as again 1 minus the error rate, the overall error, which is at 62.5 instead of 84. The specificity and the sensitivity are obtained by taking 1 minus the class 0 and the class 1 error rate. Set. This is understandable. Generate the rule and the same data is used to test the rule. When I use the validation set, it is an independent data set that is used to test the original rule and most likely will show higher rate of mistakes. My classification of the new observation is obtained here. it was the value at x1 is 50, we had x2 is 2, and x3 is 0. Now, according to the formula that we have derived, the probability that this observation belongs to class 1 is 0.1877. Therefore, since this is below 0.5, the observation is classified as 0. Example of logistic regression with partitioning. The validation data point allow me to have a better estimate of the error when the training set underestimates the error. So this is logistic regression in a nutshell for a small sample. Obviously, we should generalize that to much larger sample and many more variable and many more data. I hope you enjoy it. See you next time.